Hello and welcome to today's class. For today, we're trying to solve some past questions on hydraulics and hydrology, but majorly on hydraulics, right? So, this is first. The past questions, the year goes this way 2023 stroke 2024. So, the question says a polymetric coagulant, undiluted, has an absolute viscosity of 0.48 kg per meter seconds and a specific gravity of 1.15. The fluid is to be pumped at a rate of 3.78 liter per minute through 15.25 meter pipe with a 15.8 millimeter inner diameter. What is the head loss due to friction? Alright, let's try to solve this question together. Alright, so first is first, in science, after reading a question, your first task in science is what? List out the given parametric unit. What am I given? So solution to the question. My first task, what am I given there? My first task says that I'm given that a polymetric coagulant undiluted has an absolute what there? Viscosity. So I'm giving viscosity, that's mole. Viscosity, that's mole, right? Or you call it mu, whatever you, still the same thing. That's given to be 0.48 kilogram per meter seconds. Next up, and a specific gravity of 1.15. So I'm giving specific gravity. What then? Gravity, that's Sg to be equal to 1.15. Next task, this fluid is to be pumped at a rate of 3.78. So that rate there is called discharge. We call it discharge. That's Q is equal in value to what then? 3.78 liter per minute. Next up, through 15.25 meter. So that's the length. The length there. The length L is going to be what? That's 15.25 in meters. Right? Sorry, in meters, yes. Meter 15.25 meter pipe with 15.8 millimeter in internal diameter. So I'm giving the internal diameter, that's D, to be equal to 15.8 meters. What is the head loss due to friction? That's head loss. So I'm looking for head loss. Head loss due to friction. That's HF. Is unknown. So the question says find the head loss due to friction. First task, after looking at the parameter, before you start solving, your first task or your first priority is to check your uniformity of given parametric units. What do I mean in layman language? Check, are you converting? First is first, I'm given per se, I'm given this man here. One is in millimeter. Internal diameter there is in millimeter, right? So my first part here is that I have to convert this one here to meters because my length is in meter. Convert this one here to meter first. When you are done with that, you have to convert your discharge. Discharge Q. Discharge is simply the rate. It's simply the rate of volume, right? Or this discharge is also called volume flow rate. It can be defined as what? Volume over time. It's simply the ratio of volume over time. So that's meter cube per second. That's the SI unit for discharge. From having liter per minute, convert this one to meter cube per second. So when we are done with the conversion, you are good to go. So let's start with the conversion. So the conversion for a conversion, let's start with the internal diameter. So internal diameter, that's D, will now be equal to, this is 1 is in millimeter, convert it to meter. So multiply by what there? Sorry, divide it by 1000, right? So I'll be having 15.8 divided by what there? By 1000. So if I divide this by 1000, I'll be having, so I'll divide this one by 1000 here. So I'll have, if I divide 15.8 divided by 1000, so have is 0.015 as my value. That's 0.0158 as my value there. I'm done in what? In meters. I'm done in conversion of for internal diameter. Let's convert this charge. That's this charge. That's Q. The conversion value becomes, I'm having this one there. What's the value? This one. That's 3.78 liters times 1 over what? Minute. This times this will give you this over this minute here. Convert liter to a meter cube. That becomes 3.78 divided by what the 1000 multiplied by 1 over minute to seconds divided by 60. Multiply these two. It means that my discharge value Q will be equal to 3.78 divided by, multiply this to give 60,000. 60,000. I'll have 6.3 times 10 to the power minus 5. So in what? Meter cube per second. So I'm done with my conversion, right? 60 times 1000 is 60,000. So divide 3.78 by 60,000. You have this one here. So I've converted what I need to convert here. Next task, now let's now go ahead to find for head loss. HF is head loss. So recall that head loss HF is equal to 32 mu. This mu is what? Viscosity. Mu LV over rho GB squared. Right? So this 32, this is mu, viscosity, or call it mu, whatever you see correct. This is length, this is what? Velocity. This is rho, density. This is gravity, and this is what? The diameter, right? So first is first, I'm looking for HF. So if I want to look for HF successfully, I must know the following. Number one, viscosity. I can see I'm doing viscosity, so this is not what? This is not a problem. Check the length. I'm given length. If I check my parameter there, length is given. Yes, this is my length. I have this. Check for velocity. Is velocity given? No. So I don't know velocity for now. This is density. Is density given here? No density. So I don't know density for now. After it, gravity is given as 9.81 constant value. Density, diameter is given to. Diameter is this value here. So let's not try to get, diameter now is this value, this converted value in meters, right? So I know 1, 2, 3. This is constant. I'm left with what? 2 parameter unknown. So my first task is what? Get the 2 parameter, get velocity and get what? The density. But before I move on, I need to what? Calculate for my area. So calculating for area, that's A. First task, my area is equal to pi d squared over 4. Since I'm given diameter, it means that I can get area. So my converted value is this one now. To get area now is equal to pi into diameter. That is what? This converted value, please. Don't use this one. Use the converted value. That's 0.0158, right? Then all squared, all over 4. Multiply this. My area here is equal to multiplying of this. I'll have 1.96 times 10 to the power minus 4 in meter squared. This is my area. So since I'm given diameter, it means that I can get what areas, which I've gotten here. So now let's now go to the major priority. I need to look for two things: velocity and what? Density, rho. So calculating for velocity now. Let's start with velocity. Calculating for velocity, that's V. Recall that this charge Q is equal to area times velocity. Recall that this charge Q is equal to what? Area times velocity. At this point here, make velocity subject. It means that velocity V is equal to what? Velocity V is equal to what? Q over area. Let's get velocity here. Velocity V is equal to what's Q? Q is what then? This charge here, Q. I'm using the converted value. That's what? 6.3 times 10 to the power minus 5 all over area. Area is going to be this value here. That's 1.96 times 10 to the power minus 4. Divide the two. Velocity V is now equal to, divide the two there, 6.3 times 10 to the power minus 5 divided by 1.96 times 10 to the power minus 4. So have is 0.3232 in what there? In meter per second. Velocity, meter per second. So I'm done with this velocity. So I know my velocity now. Remember what the density. Remember density. So at this point here now, calculate for density. Calculating for density, that's rho. What's density? Density is equal to what the specific gravity, gravity times 1000. This relationship between, this formula was derived during the relationship, during the derivation of relationship between specific gravity and relative density. So this formula was derived. So this is the formula here to calculate for density at this point. So density rho is equal to specific gravity is what? 1.15 multiplied by 1000. I'll have that density is equal to, apply this value here, I'll have this. So density is what? In kilogram per meter cube. That's how we solve for density at this point here. So it means that now I know density, I know velocity. I can now look for what? Look for my HF, head loss due to friction. So from here, HF, head loss due to friction, is equal to 32 multiplied by viscosity, that's mu or mu, anyhow you call it. So that's what? 0.48. Multiply this man here by length. What's my length there? That's 15.25. I'm correct? Yes. Multiply that one by velocity. What's my velocity here? I have 0.32. So divide this one here. Divide this one here by density. This is what? 1150 multiplied by gravity, that's 9.81, constant value. Diameter is what? The converted value is what? This one here. So I have times 0.0158 all squared. So it means that if I multiply numerator, let's see what we have. My head loss due to friction, HF, is equal to, multiply numerator, right? That's 32 times 0.48 times 15.25 times 0.32 there. My answer there becomes 74.9568 as my numerator value divided by the denominator there. So I have 11, right? 50 multiplied by 9.81 multiplied by 0.05, sorry, 0.5. So multiply the denominator, I'll have this value here. Simply divide numerator by denominator there, 68 divided by. So I'll have that my HF, perhaps my head loss HF, right? HF is equal to 26.6 in what? In meter, please. In meter. So this is the value we are looking for. HF. So this is the value we're looking for here, right? HF. So if you found this class helpful, do well to hit the session, hit the like button, share to your friend and classmates. Welcome to Excellent Link Academy. Now, next class, we'll try to solve several other past questions on hydraulics, much more better.